This is Notes 12-6, Analyzing Quadratic Functions in the Calculator. So to review quickly, how do we find the vertex using our calculator? Remember, to find the vertex in our calculator, we go to Second, Trace. For the vertex, we have to determine if it is a max or a min. So that is option number 3 for a minimum, or option number 4 for a maximum. And remember, a minimum is where the vertex is at the bottom, and a maximum is where it is at the top. I need to put in a quadratic function so that I can show you. If I was looking for a minimum, I would select option 3. I start with my cursor on the vertex, and I go 3 to the left, push enter. I go back to the vertex, and then I go 3 to the right. Enter. When it asks me to guess, I press enter one more time. And it gives me the vertex. Now notice in my calculator that it has this e to the negative 6 and e to the negative 12. That just means that this x and y value are a really small number, or that they are effectively 0. So on this particular quadratic function, this parabola, my vertex would be 0. To find the x-intercepts we will find very similarly. Our x-intercepts are under the trace menu, so second, trace. And remember, another word for x-intercept is a 0, so I need option 2, 0. I will begin on the x-intercept I want to find, or as close to it as I can get. For left bound, I go 3 left, 1, 2, 3, enter. Go back to the root, or x-intercept, 1, 2, 3, back to it, and then 3 to the right, enter. When it asks me to guess, I press enter one more time. And it gives me on this quadratic that my 0, or my x-intercept, is negative 2, 0. Then you would repeat this process to find another x-intercept. Often there are 2. To find the y-intercept, we have to remember that for a y-intercept, this means that the x value equals 0, always. So, in my calculator, I'm going to go to second, trace. And since we know an x value, we are going to choose option 1 for value. We type in the x value that we need, which here is 0. X value is 0 for the y-intercept. Press enter. And it gives us that the y-intercept is the point 0, and it'll give us the y value. For this particular quadratic I'm using, it is negative 4. Okay, take a look at number 1. Graph f of x is equal to x squared plus 8x plus 3 in the calculator. Sketch the graph and then answer the following. Alright, in my calculator, I need x squared plus 8x plus 3. First, I'm going to take a look at the graph and sketch it. Oh, I notice here that I can't see the vertex, so I'm going to adjust my window. I need for my y values to go down a little more. So my y minimum right now is at negative 10. I'm going to make it negative 20 and see if that works. Perfect, now I can see my whole graph. So First, I'm going to sketch my graph. And remember, a sketch doesn't have to be perfect. It's just an approximation. Here's my sketch of my parabola. The vertex here is a minimum because the vertex is at the bottom of my parabola. To find that vertex, second, trace, it's a minimum. I'm going to go to the vertex. 3 to the left, 1, 2, 3. Enter. 3 to the right, 1, 2, 3. Enter. And guess. And I get that my vertex is the point -4, -13. Axis of symmetry. Remember, axis of symmetry is a vertical line, x equals, that always goes through the vertex. So the x value of my vertex is the point -4, -13. So the axis of symmetry is x equals -4. X-intercepts. Notice that my graph here has 2 x-intercepts. So second, trace, I need to find the zeros. I'm going to start with the one on the left. I put my cursor on that x-intercept, and I go 1, 2, 3 to the left, enter. Back to the x-intercept, 1, 2, 3 to the right, enter. Guess, enter. And I get that my first x-intercept is the point -7.6, 0. To find the second x-intercept, I follow the same process. Second, trace, 0. And I'm going to go all the way to my root. There it is. 3 to the left, 1, 2, 3. Enter. Back to the root. 3 to the right, 1, 2, 3. Enter. Guess. Enter. And I get that my second x-intercept is the point -0.39, 0. To find the y-intercept, second, trace. I know for a y-intercept that the x value is always 0. So I'm going to do value. X value is 0. Enter. 3. And remember that the y-intercept is always the c value of our function, which does match what we got. So far, so good. F of 2 equals, whenever we have a number in function notation that's in the parentheses, this is always our x value. So since we know a value, we are again going to go second, trace, value. We type in our x value of 2, enter, and we get that means y is 23. So when x is 2, y is 23, or as an ordered pair, this would be 2, 23. The range. Notice that this equation, this parabola has a minimum, so my y values are getting bigger. I'm going to say y is greater than or equal to, and the lowest spot is that y value of my vertex, which was -13. So y is everything greater than or equal to -13. Number 2, a ball is thrown in the air with an initial upward velocity of 48 feet per second. The height h in feet after t seconds is given by the function h of t is equal to -16t squared plus 48t plus 4. What will the height be when 2 seconds have passed? Okay, so in this equation, t is like our x, and h of t, our height, is like y. So we want to know a y value when x is 2 seconds. So I'm going to start by putting this into my calculator. -16, instead of t, I use x squared plus 48t, or 48x, and then plus 4. I'm going to start with my zoom, my standard zoom. Okay, I notice here that I can't see the very top of my graph, so I am going to change my window. I'm going to change the top y value, or the maximum y. I'm going to make it 40. I may need to change it again, but I'm just going to see if this allows me to see everything I need. Perfect. Okay, what will the height be when 2 seconds have passed? Or this is telling us that t, which is the same as x, equals 2. So I have a value, second trace value, 2. And I get that the height will be 36, and this is a word problem, so we need units. Height is in feet, it tells us in the problem, so our height would be 36 feet. In how many seconds will the ball reach the maximum height? So maximum, this is the vertex, and how many seconds we want t, or the x value of the vertex. So my vertex is a maximum, so second trace maximum. I'm going to start with my cursor on my vertex. That looks pretty good. I'm going to go 3 to the left, 1, 2, 3, enter, back to the vertex, and 3 to the right, 1, 2, 3, enter. I get that my vertex is 1.499, and I'm actually going to call that 1.540. So we would say after 1.5 seconds, the ball is at its maximum height. What is the ball's maximum height? So we are looking here for a height. This is the y value of the vertex, which was 40 feet. At what time will the ball hit the ground? So our graph looks something like this, and we know that on the ground, this is where the height is 0. So we want to know if the ball goes up and back down when height is 0, or we want to know the x-intercept. So second trace, I need the 0. I'm going to go over to that spot where the ball hits the ground. Okay, that's as close as I can get. So I'm going to go 3 to the left, 1, 2, 3, enter. 3 to the right, 1, 2, 3, enter. Guess, enter. And I get that the time is 3.08 seconds. What is the domain for the function h of t? Normally for parabolas, when we are not working a word problem, our domain is all real numbers. But for word problems, we only need a specific what is meaningful to this problem. So domain means x, which in this case is time. We know that time cannot be negative, so our time has to start at 0. And then our time ends in this problem when the ball hits the ground, which in part D we found was 3.08 seconds. So our domain is between 0 and 3.08 seconds. Okay, number 3 on the back, we're going to go through this really quickly. It says the equation y equals x squared minus 12x plus 45 models the number of books y sold in a bookstore x days after winning an award-winning author appeared at an autograph signing reception. How many books were sold on day 4? So I go to y equals, I'm going to type in my equation, x squared minus 12x plus 45, starting at zoom 6. And I see I can't see any of my graph. It's all way up top. So I'm going to change my window. I'm going to drastically change my y max to 50. Okay, and this is much better. So after how many books were sold on day 4? So day 4, it says x is days. So I have a value for x. I'm going to go second trace value. My x value is 4. I get y is 13 books. What was the first day that at least 100 copies of the books were sold? This is y equals 100, so I'm going to go back to y equals and change y equals 100, which means I need to change my window so that I can see above y equals 100. Okay, and I can't see in the positive time where it crosses, so I'm going to change my x max to 50 and see if I can see better. I can now see where it crosses, so second trace intersect. I'm going to get somewhere close to that spot. Okay, enter, enter, enter.